Today we are going to discuss website called civildesignanalysis.com. It has 3 pages: beam analysis, retaining wall, and footing design. Today we are going to only discuss beam analysis, and we go there. Beam is civildesignanalysis.com and press beam analysis. We'll see this page comes up. It's on the left side. It asks for the defining the beam, and on the right side it will later on show the beam and analyzed beam. So let's go to the left side, and for defining the beam. If you look at these units, it is in US right now. It's in default, and you can convert this into SI units or an international system. Or we will leave this as US system, and we're gonna define like 15 feet beam span. So you can define 15 feet beam, and by default it shows a simply supported beam with 2 supports on each side at the end of this support. If you look at it, support 1 as is at 0 feet, and support 2 at 15 feet. And if you look at this support type, this is pin right now and pin by default. You can change it to fix. Look at this. You can change it to fix, and you can put it back to free. You can put it as free, but be careful with free. You might be making the beam unstable. So I'm gonna leave this as it is, or you can have, if you wanna have a fixed here, you can also have a pin on the other side, but you can make it free. So this is gonna be a cantilever beam. This is a stable beam, but we're gonna go back to the simply supported beam. So we're gonna do that, and let's work on the example with the number of concentrated forces. So as we go here, you can have less than 5 or 5 types of concentrated load at different location. As we put two concentrated load is asking for the force 1 located at so much feet, and the magnitude of the force, and the same thing is for the second part, and then the magnitude of force. Then here is the direction of the forces. Let's go and do it with one concentrated load, for example, and then we're gonna go and put here 2 feet from the left side, and then magnitude would be 5 chips. So as soon as you define the beam with the loading condition, it will show you all the results here. First of all, check the reactions here. 4.33 kips is on the closest side of the load, and then at the further side is 0.67, which makes sense. So you have complete loading with the reactions there. So now look at the shear diagram. The shear diagram starts at the left side, 4.33 kips, which was the reaction, and then there is a constant shear, and then it goes down to 0.67, which makes sense. And then this is the shear diagram you have prepared. And then on the bending moment, you can see that the bending moment, it shows the bending moment maximum is 8.67 kips feet at 2 feet, which makes sense that it is at the point of location where the load is located. So 8 point. If you theoretically see this, for this kind of loading, you have theoretically you have 2 times 13 divided by 15 would be 8.67, and further we go to the displacement section. So the displacement is showing at the maximum displacement is 6.42. So this makes sense. It is away from the load, and then we have from the load. You can have because of its elasticity, the maximum load go away from the point of loading. So it makes sense that it is completely theoretically it's correct. You can also do that by putting here, as instead of 2, let's go to the 13 feet, and you can see that it's exactly the same, but in all the opposite direction. So you can see it's the same bending moment, and look at the location of the maximum displacement, which is further away again at 8.55. If you calculate this from the loading diagram of steel book, it will give you the same location for this kind of loading. And you if you go and change to the units, it will give you an SI unit. It will now be in kilonewton, and meter from 15 feet to 4.57 meter. So this is how you do it. You can also change the direction of the loading up. So as soon as you do this up loading, you have shows the opposite direction. We're gonna leave it like that. And one more thing, we can add also the number of uniformly distributed load, which is we can go with one load and apply the uniformly distributed from 0 to all the way to 2 meter, and we can have about 4 kilonewton meter. So you can see that how this beam is loaded with distributed load. We go back to the US system. We can go from 0 to 15 feet, and then it's going to go all the way to the uniformly distributed load. And let's do it with 1,000 pound per foot. So as soon as you see this will be like 33.4 feet. And again you have a displacement here with a uniformly distributed load. Please, I want to tell you that you have this civildesignanalysis.com. It is based on the finite element method. It's the only website that you can see for the website of finite element method. It is that's the reason it is so flexibly allow all these things to happen with the different support, with the different loading condition and location, and the uniformly distributed load. You can combine these and look at the maximum is where the shear is 0. So try to do this, and please go to civildesignanalysis.com, and you will get this software for your beam analysis. Thank you.